The Dwyer Instruments Incorporated Magnesense Differential Pressure Transmitter Installation and Operation Video. This instructional demonstration covers the installation of a Magnesense differential pressure transmitter in typical applications. The first application will show use of the transmitter in monitoring a duct's static pressure. Next, we will demonstrate how to properly connect a differential pressure transmitter to monitor the pressure drop across a filter. Last, we will demonstrate how to connect a differential pressure transmitter to a pitot tube to properly monitor airflow in a duct. The Series MS Magnesense differential pressure transmitter uses a high-quality Hall sensing technology, which enables it to provide a high level of performance over many years. Remove the Magnesense transmitter from the package and inspect for any damage that may have occurred during shipping. Note that each package contains a product, sticker label sheet, and installation manual. The sticker labels are provided as the product has the ability to read in various engineering units, which we will discuss later in this video. On the transmitter, note the silver model label on the side that provides the model number, the appropriate power supply required to power the transmitter, as well as the maximum pressure the unit can withstand. This information will ensure you are using the right product for your application. With regard to electrical ratings, the Magnesense transmitter is available in two versions. One that provides a 4 to 20 milliamp current output, and another that provides a 0 to 10 voltage output. Models providing a current output can accept 24 volts DC on a 2-wire loop, and models providing a 10-volt output can accept either 24 volts DC or AC on a 3-wire loop. The Magnesense transmitter includes a metal bracket inherent to the body for quick, simple installation on a wall or duct. The transmitter should be mounted on a vertical surface with the connections directed down to prevent moisture from entering either the pressure ports or the electrical cable entry. This also places the diaphragm in a vertical plane, which minimizes gravity effects on the diaphragm. Make marks on the duct using the transmitter's bracket as a template to properly position 3 pre-tapped mounting holes. Mount the transmitter using 3 number 8 1/2-inch pan head sheet metal screws in the metal mounting bracket. Do not over-tighten. Now you are ready to wire the transmitter and set the unit into one of the various modes required for your application. First, twist off the cover to access the internal circuit board. Twist the cover counterclockwise. Notice on the lower left of the circuit board the screw terminal block. This is labeled TB1 on the circuit board. Bring 16 to 22 gauge wire up through the electrical entry. Note we are using a 1/2-inch conduit adapter to connect to 1/2-inch conduit for final installation. Wire properly per local wiring codes. With a small screwdriver, loosen each screw on the electrical block. Slip wires into the appropriate connector on the terminal. Each connector on the terminal block is properly identified on the circuit board. Tighten until wires are secure. Check the wiring diagram on the installation manual provided to wire properly per the model and output you are installing. Now you are ready to place jumpers in their appropriate positions for your application. Printed on the circuit board is the designation PJ3. If you have a model with selectable ranges, there will be a jumper present that will allow you to choose one of 3 preset ranges. H, M, and L printed on the board stand for high, medium, and low ranges. Check your model to see which 3 ranges you can select from and set as needed. We will first show how to connect a Dwyer differential pressure transmitter to monitor a duct's static pressure. Tubing with a 3/16-inch internal diameter is the ideal tubing for the pressure ports on the bottom of the Magnesense. Dwyer Instruments Model A220 vinyl tubing with 3/16-inch ID is the tubing we will use in this demonstration. In this application, simply connect the tubing to the high-pressure port of the Magnesense transmitter located on the left. Leave the low-pressure port on the right side open or vented to the atmosphere. Note that on the bottom of each pressure port are imprinted identifiers with words and symbols of H, I, and plus on the left port and L, O, and minus on the right port. Now we are ready to connect the tubing at the other end to a pressure sensor that will sense the static pressure in the duct. Dwyer Instruments Incorporated offers several static pressure sensors and static pressure tips that can be used in this instance. The most common static tips are the A302 with barbed fitting and mounting washers, and the A303 with barbed fitting and inherent mounting magnet. We will use a model A303 static pressure tip with mounting magnet as our static pressure pickup in this scenario. Align the tip's point in the direction of the oncoming airflow. Though there is no sensing at the end of the static tip, this alignment prevents any airflow pressure disturbances on the static pressure sensing points, minimizing fluctuation and errors in the static readings. Dwyer Instruments Incorporated offers an option on the Magnesense transmitter that will simplify installation in this duct static pressure application. An inherent static pressure probe can be selected at the time of order that will alleviate the need of using tubing and static pressure sensors. The elimination of these parts will dramatically simplify and reduce installation time. To mount the Magnesense transmitter with the inherent static pressure probe, simply drill a 0.56-inch or 12.7 millimeter diameter hole into the duct. Insert the transmitter probe into the duct. Next, mark the location of 3 mounting holes on duct using the mounting bracket as a template. As shown earlier, drill 3 pre-tapped holes. Now you are ready to attach the mounting flange to the duct with 3 number 8 1/2-inch panhead sheet metal screws. This is all that is required to monitor the duct's static pressure due to the inherent pressure probe connected to the body of the Magnesense. No separate pressure sensors or tubing is required. Simply wire and set the transmitter as necessary, and your installation is complete when using this version of the Magnesense transmitter in static pressure applications. We will now demonstrate how to properly install a Magnesense differential pressure transmitter in a filter monitoring application. If you have an application where you need to monitor a differential pressure across a filter, both pressure ports must be connected on the transmitter to static pressure sensors or static pressure tips. We will choose in this example Dwyer instrument models A308 and A345 static pressure sensors as our static pressure pickup devices. The pressure sensor model A308 is used when the installer has access to the inside of the duct. A washer and tightening nut allow the installer to mount and tighten the barbed pressure pickup from the inner side of the duct. Drill an approximate 7/16-inch diameter hole. Next, position the barbed fitting with a washer on front and back. Hand tighten the nut on the backside washer. Tighten the barbed fitting with a 7/16-inch wrench. After mounting the A308, connect the pressure tubing to the barbed connection. When the installer does not have access to the inside of the duct, the model A345 pressure sensor is the perfect choice. The A345 contains a mounting flange with rubber gasket, a barbed fitting sensor, and 2 screws. Drill an approximate 7/16-inch hole. Mount the flange and gasket with the screws, then thread the barbed fitting by hand into the flange's hole. Tighten the fitting with a 7/16-inch wrench. Once mounted, connect the pressure tubing to the barbed fitting. To properly monitor the filter's capacity level, connect the high side pressure port on the left of the Magnesense transmitter to the pressure sensor that will be installed upstream of the filter. Connect the tubing to the low pressure port located on the right side of the transmitter to the pressure tip or sensor that will be located downstream of the filter. The differential pressure will increase gradually as the filter gradually traps debris. If you see negative readings on the transmitter, then the connections are reversed and need to be switched. The last installation application we will demonstrate is the installation of a Magnesense differential pressure transmitter used to monitor the air velocity in a duct. For a differential pressure transmitter to sense air velocity in a duct, a device called a pitot tube is most typically selected as it is the most simple to install. We will use a Dwyer Instruments Model 160-8 pitot tube, which has an 8-inch insertion length. For best results, it is recommended the pitot tube be inserted in a location in the duct that has a minimum of 8.5 diameters upstream and 1.5 diameters downstream of straight run in the duct. Thus, no elbows, contractions, or expansions should be located 8.5 diameters upstream or 1.5 diameters downstream from the pitot tube's insertion location. Review the Dwyer Instruments topics on airflow in the Engineering and Applications Guide, as well as the Series 160 Catalog and Instruction Manual for additional information on proper location and installation of a pitot tube. To mount the Series 160 pitot tube, we will use two accessories available from Dwyer Instruments. The first is the A156 pitot tube mounting flange, and the second is the A159 pitot tube mounting gland. The A159 comes with the following parts. The washers and locking nut will not be necessary when utilizing the separate A156 mounting flange, but would be used if the A156 mounting flange was not installed and there was access to the inside of the duct. It is very important that the A159's components adhere to the following procedure in order for it to secure properly on the pitot tube. Each component of the A159 must be slid individually around the 90-degree bend of the pitot tube. First, slide the smaller threaded connector nut with the male thread around the bend towards the top, with the threads pointing back to the 90-degree bend. Next, slide the steel spacer followed by the graphite compression seal. Finally, slide the largest mounting nut with 1/2-inch NPT male thread around the bend. Once all components have been properly positioned on the pitot tube, put the graphite compression seal into the larger mounting nut. It will stick into the base of the nut. Next, place the steel spacer onto the graphite seal inside the nut. Last, thread the smaller connection nut with its male thread into the female threads of the larger mounting nut. Just finger tighten at this point so the A159 can slide up and down on the pitot tube. You are now ready to put the pitot tube with installed A159 mounting gland into the A156 mounting flange. Tighten the larger 1/2-inch nut of the A159 into the A156 mounting flange. Once secure, slide the pitot tube in or out to the desired insertion depth and tighten the smaller connecting nut of the A159 so that it will compress the graphite seal and lock the pitot tube in place. Ensure the tip of the pitot tube is pointing perfectly perpendicular in the airflow's direction by using the longest pressure connection as a gauge to align the pitot's sensing tip inside the duct. You are now ready to connect the tubing from the pitot tube to the Magnesense differential pressure transmitter. Connect the longer pressure connection on the pitot to the low pressure port or port on the right side of the Magnesense. This connection on the pitot tube is sensing the static pressure in the duct. Now connect the shorter pressure connection on the pitot tube, the one that is pointing back at you, to the high pressure port on the Magnesense located on the left. This pressure connection will be sensing the duct's total pressure, which is comprised of both static and velocity pressures. The Magnesense differential pressure transmitter will sense the difference of the pitot tube's static pressure and total pressure to give solely the velocity pressure of the airflow.